Hello, this is Mrs. Boyd, and today we are going to be talking about covalently and ionically bonded atoms that will form molecules. And the first thing is we need to kind of know the difference between the two. So covalent, as the name implies, meaning to share, kind of together, and valent implying valence, so maybe outer shell electrons. Sure enough, covalent is when two atoms are going to share electrons, versus ionic bonds are when atoms are going to steal or give electrons to each other. Another difference is covalent bonds are formed between nonmetals off the periodic table, and ionic bonds are formed between metals and nonmetals off the periodic table. So let's take an example. Here we have carbon dioxide. Carbon and oxygen are both nonmetals, and they do this beautiful thing where they share their electrons. That's because the electronegativity difference of these two atoms is not really all that strong or big, and so neither one of them is really pulling that tightly on their electrons, and so they just do this very harmonious sharing process. So that's an example of when they share electrons. And then over here on the right, we see that we have an example of ionic bonds. And this is when, let's take for example, lithium. Lithium has an inner shell with 2 electrons inside of it. This makes for a complete shell, but the problem is we have this extra electron up here at the top of lithium that's kind of like masking that beautiful full outer shell. And so if lithium can get rid of that electron and give it to something else that really wants an electron to have a complete outer shell, then lithium becomes very happy. So sure enough, lithium is going to take its outer shell electron and it is going to give it over here to something like fluorine. And that donation right there causes these two atoms to become ions, because lithium now lost an electron, and so it is going to be a little bit positive, and fluorine gained one, and it's going to become negative. And so what you have here now is this attraction between a positive and a negative ion, and that is what we call an ionic bond, is that attraction. So these are salts over here usually that are ionically bonded, and covalent are things like water and sugar and other molecules like that. So I have chosen 2 different molecules to build for my project, and the first one is water, H2O. The second one is table salt, sodium chloride. And so let's first find out which one is the covalent one and which one is the ionic one. To do that, we'll need an electronegativity chart. Of course, you can also just take a look and find out, are they both metals? Are they both nonmetals? Do we have one of each? But we can also do it mathematically. So let's take hydrogen and oxygen that makes up water. Hydrogen has an electronegativity value of 2.1, oxygen 3.5. So let's go ahead and do the subtraction. 3.5 minus 2.1 equals 1.4. And then we have this handy dandy little chart right here that is going to tell us whether that difference in electronegativity puts us in the range of a covalent or an ionic bond. So 1.4 is going to fall somewhere in here, and that is in the covalent range. So our water molecule is going to be our covalently bonded molecule. Do the same process for sodium and chlorine, sodium being 0.9, chlorine being 3. So let's do our subtraction. 3.0 minus 0.9 equals 2.1. And again, using our handy dandy chart here, 2.1 is going to fall right there somewhere, which puts us in the category of an ionic bond. All right, so let's go ahead and show you how these are drawn and how we kind of put these molecules together. So water is covalent, so we know that it's going to be sharing electrons. First thing you always do is Lewis structures or Lewis symbols for our atoms. So hydrogen, being in the first group, has 1 valence electron. Oxygen, being in group 6, is going to have a total of 6 valence electrons. And the beautiful thing about this is not only does this show us how many electrons there are, but it also tells us how many bonds each of these atoms wants to make to fulfill the octet rule or have a full outer shell. So hydrogen has this one lone electron, so it's going to make one bond. That will make hydrogen happy. Meanwhile, oxygen has two unpaired electrons, so it's going to be content making two bonds, because then it will get two full outer shells. Hydrogen will have two, and oxygen will have a total of 8. So let's see how we can put this together. Here's oxygen with its paired electrons already shown, and we know that it needs 2 additional bonds so to keep it happy, and then we know hydrogen needs 1. So we kind of do a little bit of puzzle solving there, and we determined that we can keep our hydrogen happy by giving it 1 bond, our oxygen happy by giving it 2 bonds, and that is how we are going to complete the puzzle on how to make a covalent bond. If we look a little bit further down here, we have a 3-dimensional structure, the ball and stick model. The stick is representing 2 electrons being shared, and then of course we also still have to put our paired electrons outside of that oxygen, and that actually determines the shape of this molecule, because those outer electrons, those pairs that we see witnessed here and here, are actually pushing down those hydrogens on that oxygen, and that's why we get the bond angle of 109 degrees. The way that these kind of symbols work is that dashed line means those 2 electrons are behind, going down behind in the plane of the iPad, and then these 2 over here are actually coming out at us with these hydrogens being exactly in the plane. And this is called a bent configuration, and that is the shape of our molecule. So that's how you put together a covalent bond. Let's take a look at an ionic bond. So remember, with ions, you're stealing electrons or giving electrons, so it always has to be between atoms that have great differences in electronegativity. So someone wants an electron and someone wants to give one away. So in this case, sodium only has the 1 in the outer shell, desperate to get rid of it to reveal the inner shell that's full. So when it does it, it's going to become sodium plus 1. That will be its new ion because it gave away an electron. And chlorine gains 1, so it will become negative 1. And now we have a positive and a negative ion, and they are attracted to each other. So we kind of showed this with this dotted line here. We would never use the ball and stick model for this, because the sticks represent 2 shared electrons, and here we have an attraction between ions. It's simply that. So here we have sodium and chlorine shown using the balls, but we can't actually connect them. We're just showing the attraction. So a few fun facts. Salt, interestingly enough, was used to pay Roman soldiers back in the day when they didn't have enough coins, because it was literally that valuable. And my other molecule, my covalent molecule, water, super important, everybody. Stay hydrated out there. Helps lubricate your nerves, and is now implicated in memory and focus. So key to success. Thanks for watching.